Well, hi, good morning. Thanks so much for joining me in my shop. Today is November 7th, another nice sunny day here. And yesterday's video was a bit of a runaround, doing some experiments, trying to visualize or see some effects in the radio. Kind of went so-so. Well, today's going to be very similar. I'm just going to move the location where I'm investigating the radio from the output of the mixer tube to the output of the IF amplifier tube, and we'll try to see what's going on in the first stage of the IF. So the first thing I'm going to do is I'm going to relocate my sampling capacitor, if you like, from here down to this tube, and then we're going to get busy and see what we can see. Okay. Now the radio's not on. I do have the SDR connected. I'm just going to disconnect the SDR antenna lead for a moment here. Well, that's kind of an interesting thing in itself. The upper frequencies being picked up by the SDR. Now what's that stuff right? I guess I can point like this. What's the stuff right up here? That's not changing, but I took my finger on and off the antenna. Good question. Don't know. Now if I hook this up, that suppresses the higher frequencies. A little bit interesting in itself. It leaves junk there. My hand is doing something. So I have my signal generator operating, but it's not connected just yet. And the radio's not on. This shouldn't do anything, should it? Tuning the radio. No. Nothing I can see anyway. Okay, we're ready to go. What do we expect to see? So at this location in the radio, in the simplest sense, there's only one thing, and that's the IF frequency band, pass band, right around 460. So maybe signals from 440 to 480, something like that, may show up. And that is just down in this part. Well, it's down where the red line is, right above my finger. That red line is set on 460. That's the center of the IF. So that's where all the action is. But when I first turn the radio on, we'll look at the whole band and just see what happens here. Tune around a little bit, and then I'm going to zoom in on the IF area, and we'll take a look at that. You know, unless something extraordinary happens here. Here we go. Certainly, once again, putting my SDR radio at a bit of risk. What's life without risk? Okay, well, let's turn out. Oh no, not a cat. So you can see the general operation of the radio appears to be really suppressed. Look at the fantastic signal down in the IF area. That's a huge signal coming through. So you see on the waterfall display, you see two vertical lines. One is in the middle of the IF, and the other one is the local oscillator. Let's just prove that. Yeah. Now if you look at the IF, just watch. When we zoom in, this will become really apparent, but you'll see stuff rolling through it. This is exactly what should happen. This is good. This is a good result. Wow, it's pretty strong. I guess I could have put maybe a smaller capacitor here. Okay, but we're not going to hear anything. Oh. Something fairly good here. Just loud. Some noise signal. It's fairly loud. Does that qualify as fairly loud? We're almost at the end of the band here. Okay, so you know what that sounds like. There's that tick 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 interference. What was that? Oh, there's a cat inside this radio. So there's a little peak there, right where the local oscillator is traveling. That just has to be a coincidence. What was that other stuff that just popped up to the left? More things I cannot explain. Okay, let's stop here where this sound is. I'll turn down this radio, and I'm going to turn the sound up on the SDR. And we're going to hear what the SDR is hearing, rated 460. That was just a little unexpectedly loud. Wow. Okay, tune the radio. We're listening to the SDR now. Oh, that's the volume control chip. The station there. Now there's a delay between what you see and what you hear. So don't be confused. It confuses me all the time. I'm going to take this right off here. So we're picking up. Oh, look at that. That's as quiet as I can set my SDR. It's a very powerful signal for the SDR picking this up. No surprise. They expect it to be strong at this point in the radio, the IF. This is interesting. This is kind of interesting. That's what's available to this radio in the middle of itself. A signal of that quality. The tone was a little low. It's probably maybe bandwidth on the SDR or something making it a little muffled. I don't know. Don't fool with that yet. What is coming out of the speaker on this radio? Tune it right in here. It's exactly the same as tuning the SDR with the SDR set at 460. It means the alignment of the IF is good, at least to this point. Now, how do we compare these two? Like, what I'm thinking is, we're sampling the signal partway through the radio. I'm using another radio to demodulate it so we can listen to it. And it sounds pretty good. Let's put it on again, see if I can even improve it here. So this is the SDR.
You can go and I bought some Alvin sauce, alright? I bought some.
Okay, we'll check the bandwidth here. It's 5,000. Increase the bandwidth.
I'm a little bit filed away now. Whereas all I'm saying is sell your stock at game 52 or so before things get heavy. Just continue, jack that price up and then pump and dump. That just made sense. That hurt me because it made me think about, some investments pretty...
So the bandwidth shape, let me turn the sound off here. Yeah, so many things to talk about at once. Sounds better on the SDR than it does here. Is that telling me that the radio is producing a pretty good result up to this stage, and then somewhere between here and the speaker it kind of goes downhill a bit? That it's the radio itself, it's indicating where there's a weakness in its function? I don't know. Another thing is, as I expanded the bandwidth, at some point I caught hold of this guy right here. This one right here. Can you see that little peak there? And as soon as that became incorporated in the reception of the SDR, it began to produce a heterodyne signal, a very annoying, high-pitched heterodyne signal. So I shrunk the bandwidth back down to escape that. Now, the bandwidth is very sharp on these digital radios. It's not the same as a regular radio here. The roll-off, if you like, is very sharp, very fast. So you can literally move the bandwidth right up beside something. Just don't go a little bigger, you hear it. Go a little quieter, you don't hear it. If you're fooling around with SDR radios, then you've probably encountered all of this already. That's what I'm doing, a lot of shortwave listening and ham radio stuff using SDRs with these fantastic filtering features and that. And you can exclude these adjacent noises that you cannot exclude with a radio like this because the bandwidth rolls off slowly and it's fairly wide and you can't fool with it. Not a little radio like this. Not easily, not from the front. There's nothing on the front that you can do to change the bandwidth. Not on a little radio. So that's pretty interesting in itself. Let's zoom in on the area here of interest. That's right in here. And just zoom right in on it. Okay. Now it looks a little different. I think, let me just zoom out again a bit. Yeah, so I was guessing this was the noise we were hearing. That's not right. This is 430. This is 460. That's 30 kilohertz away. The sound we were hearing, well, I'll bet you it's this one right here. I'm going to full screen this for us here. Get a little better look at it. This is what we were hearing. I couldn't see this on the larger display. Now on this SDR, on the software I'm using, the bandwidth you're listening to is indicated by this light shaded area. And you just grab the edge of it and move it. You can shrink it and expand it. So I'm going to shrink it. We're going to listen, and then I'm going to move the bandwidth of the SDR back and forth. If you don't have an SDR, if you're a shortwave radio listener, you don't have a radio like this, you better get one. That's what I would say.
Actively every week for the Broncos to lose because the Seahawks have their draft pick. Like that works. So every interception throws, I'm just celebrating like it's Super Bowl for me. But no, Freddie Anderson, I think, got a bit of a bum rap in Toronto, and I always kind of went like, this is one of the ugly reasons of playing in this market is sometimes guys become whipping boys and then nobody ever lets it go. Like it just becomes the thing that you're like, he's going to talk about hating Freddie Anderson.
If you listen very carefully, not only can you hear this one come in, but you can hear this little one here. If you listen very carefully, it's a higher pitch. Listen very carefully.
To face, like that's no good. I'd like to see them keep the two AHL guys in net. I'd like to see them like prove for a little while that they can continue to be that tight defensive team that can counterpunch and beat you at times. I think that will show a little bit of team toughness. I think that maybe we get a look at, I don't know what this Petrozelli kid is. I know he's got some
Oops, got 460. So the radio's not exactly tuned. If you look at the 460 line, it's not dead on the peak. So I'm going to tune the radio. Watch what happens now as I tune the radio.
Who knows? Maybe you do hit on something. I think I've learned enough. How many of those missed the net by Carolina? How many bobbles were there in that game?
Now, I've got the SDR set right on this other signal. Probably just a noise signal here in my shop. The radio signal is now outside of the bandwidth of the SDR. Barely hear it. But we don't hear much from this interfering signal. Where's the tone? So the tone we're hearing is the difference in frequency between the radio station and this thing. Which is, if we look at, that would be about, it's 454, maybe 4 kilohertz, something in that range. And that's the pitch of the tone we're hearing, something like 4 kilohertz. The reason we can't hear this tone all by itself is there is no modulation in it. It's just a carrier, if you like, with no modulation, or the modulation so low it doesn't matter. So now if I stretch this out to incorporate that guy, ooh, that's hard to listen to, isn't it? Let's go back to now. I'm going to just tune the radio in one direction and just watch what happens. Let me move this out of here. Okay, so just watch what's going on. I'm going to tune in one direction. Now that's the volume control, Jim. Keep trying to tune this radio with the volume control. Here we go. Now, do you see it? It's a parade of signals rolling through. There's a big one there. I wonder what that is. Okay, I'm just going to keep, just, you know, I can get sidetracked. I'm going to some beeping sound you may have heard in the background. That's a ham radio telling me the battery's going off. You see all these interesting things rolling through there as I tune up. Oh, something going the wrong way. What's that? I don't know. Just keep rolling up. We're listening where the red line is. We're actually listening. There's a little thing there. If I put something there, maybe you can hear that. It's very quiet. The volume's set very low on the SDR. There comes a bigger thing. So we're looking at now at 485 kilohertz, where the red line is, where the SDR is tuned. 485, and there's a substantial signal there. In my view of this, the radio is not successfully suppressing this other signal. You really only want things, say 10 kilohertz either side of 460. Maybe only 5 kilohertz, in fact, either side of 460, to give you the proper bandwidth for a regular broadcast station on AM. But here the radio on the output of the IF amplifier tube has got a signal way up at 485. Now, there's another stage in the radio coming that we're not paying attention to yet. So this signal might get, well, it will get suppressed further by the response curve of the next transformer. But we're not there yet. Now, what does the radio sound like? I'm going to flip back to the camera here. Maybe something else. This is a little hard to get into your head if you're new to these kinds of radios. These are frequency conversion radios. They convert whatever signal it is you want to listen to, they convert it to 460. But they don't just convert the one signal that you're interested in. They're converting essentially the whole band, more or less. There's a certain roll-off because of the antenna tuning. So we go a fair ways from where you've got the radio tuned, and the roll-off may suppress it, but it's not much of a roll-off. And I think in these cheaper, simpler radios, it's really not much at all. So the radio is converting everything that's on the antenna and presenting it to the mixer tube. And then out of the mixer tube comes everything frequency shifted. You can think of it that way. So you have these signals, which I guess it would be this way. Here, this is easier for me to do. Use my right hand. So I have these signals, and as you're tuning, in effect, you're moving up and down the signals. You're actually tuning the radio like this, sort of, up and down the signals. But now you're converting them to another frequency. There they are. Now they're converted down here. So they exist up here, and they've been converted down here around 460. They're all there. And now as you tune, at 460, what we're looking at in the eye, they're all rolling through. Like that. That's what we're watching when I'm tuning and you see that stuff. You're actually seeing what's on the antenna at a higher frequency after being converted. And so everything is in there. Everything is in there. Now what we want to do is want to set this, we want to listen first. The SDR will tell us what that signal is. And I'm tuning on the red line. Okay, SDR, tell us. Just kind of a roar, not much else. And now, what do we hear from this radio? Nothing really. Now remember, the speaker here is further along, right? There's another stage of IF, one of those things in the second IF stage, and then there's the detector, and so there's a lot of stuff going on before it gets to this speaker. I'm grabbing it with the SDR before a number of things happen to process the signal further in the radio. So we're not hearing that. I don't think we're hearing that at all. So we can watch the SDR, we can listen to this radio, and see what we hear. That's the volume control, Jim. I keep so some very strong noise signal there. The frequency actually is around 710. Again, tuning down. Notice there are some signals traveling up. A very curious thing. Think about that. So you're moving the local oscillator. That's really what's going on here. And you can have a signal on below it and a signal above it. So as you tune the oscillator this way, you're approaching this signal, and the difference frequency is going down. Down, down, down. Meanwhile, the one that's over here, the difference frequency is going up. So maybe that's where the up and down is coming from. Depends which side the signal's on. And these signals would have to be close to the local oscillator minus. Oh, there's another thing. Minus 460 or plus 460. The idea in these radios is, because the local oscillator is going to convert any signal that's 460 away from it. And this is the local oscillator. I'm not pointing at the display. I'm just showing you my own graph. Here's my own. I am the radio now. I am the SDR. So there we are. The signal's all across it here. Any that are 460 away, maybe 460 away, are going to come out of the speaker on either side of it. The thinking is the other tuning elements in the radio, in this case just one tuning element, that's the tuned antenna, with the capacitor I'm changing, is tuning this one. Okay, there's its response curve. The other signal that might be 460 away is depressed or suppressed by this curve. So if there is a signal up here, you shouldn't be able to hear it. Particularly when you tune radios like this, you tune them to a station, right? You don't tune them in between stations. You tune them to a station, and that station comes through the radio. Its own audio covers anything else that might be coming through accidentally from what is called the image frequency. And at the same time, it's suppressed by the front-end tuning. But when you're tuning between stations, I'm just thinking about this now, the radio's sensitivity goes up because there's no AVC, assuming there's no loud signals, no loud interference signals. It goes way up, and as you tune, your ear, you can't tell whether things are going through the IF in this direction or that direction, or whether they're coming from above the local oscillator or below. You could easily tune the radio to a place where there's no signal 460 below. There's nothing but just some quiet noise. Meanwhile, there's a strong noise signal 460 above, and it can beat the suppression that the radio's attempting to do on it. These problems are not so serious in a radio like this for a couple more reasons I won't go into. But when you look at a shortwave radio that's using the same kind of IF frequency, 455, 460, and you're working up at a very high frequency, like 18, 20 megahertz, in that case the suppression is very poor because the bandwidth apparently looks really big. So if you do have your good 460 down here, if I can call it that, you got your bad 460 up here, you can still hear it. And so that's why often on a shortwave radio you'll find a statement in the information about the radio about image suppression, and the suppression is coming from this front end trying to keep it out entirely, so it won't get in, won't convert with the local oscillator, won't come out the speaker. So I'm going into great deal on this because it helps me a lot to clarify my own thoughts. Now, I've been doing this my entire life. I've understood much of this since I was a kid, but never understood it at a really good level, that I really get a real grip on it. Particularly so when I'm tuning the radio, I'm well aware of everything that could be happening. it's taken me to this point. You know, I'm 21 years old now. No longer a kid. Yeah, I'm a little older than 21. And this is all helping me clarify what's really going on, because you don't read this stuff in a book. Not quite. They certainly talk about image frequencies and stuff like that, but they don't really get into it to this level. So lots of fun. Okay, now what are we finding out about this radio? Nothing too surprising yet. What we found out is it seems like if you sample the signal halfway through the radio, you can get a better version of it through an SDR radio or any other radio. You can hook up any radio here. Wouldn't recommend it, but you could hook up the antenna here. You have to have a radio that can tune 460, so that's a little unusual. I guess you could take an old AM radio and push it, so it might reach all the way to 460. The 460 is not far below 530, the start of the AM dial. Just another one of the differences here, just to make it really clear. There's a large frequency range in these radios when you're tuning them. They start at 500 and they go to 1500. That's a factor of 3 in terms of the difference in the frequencies. Well, you took out a shortwave radio and it might go from, let's say a band might go from 10 megahertz to 20 megahertz. That's a factor of 2. And this it also has this effect of making the image more likely to be encountered in a high frequency radio with a low frequency IF. If the IF were of higher frequency, let's say it's a megahertz or 10 megahertz, then that stretches everything out, and then the roll off in the front end of the shortwave radio will be more effective. And this is where double conversion radios come from. That's the whole idea of the double conversion radio. The very best radios are double conversion. When you get up to a higher frequency band, the radio does this local oscillator conversion thing twice. It will usually use a higher frequency, often 10.7 megahertz. And I certainly have a military radio that has it's a double conversion, and on the higher bands the second converter kicks in, and so you convert it first to an IF of 10.7, and then that signal is further converted down to an IF of 4.5, probably to utilize existing circuitry at did I say 4.5? 455. And that's how they manage to overcome the image problems. What else can we do here now? Some more interesting things. Well, I have my signal generator operating. Well, let's just hook it up. So I'm going to hook this to the antenna. A little pop with some DC charge, I believe. Not what you want to hear. So my signal generator is running at 600 right now, and I didn't do anything to this radio. The radio is tuned to, well, let's make this easy. I'll put this up at 1,000,000. Wow. I wasn't looking at the screen when I was tuning it. Some pretty fancy looking designs down below there. Okay, back to 1,000,000. So much fun. And now I'm going to roll the signal generator through 1,000,000 hertz. You know what, I'm going to change this because the 1,000,000 is very difficult to dial in on this. It's a hassle. It's right at the band change. So I'm going to put this down to 800. Get radios at 800. I'm going to put the red line back on 460. So that's the center of the IF. Anything there is what we hear coming out of the speaker. Wow, that gives you a real X-ray view of what is going on in this my shop here with noises. Okay, back to 800. Nice quiet spot, sort of. Something else just came to mind. I'm just going to try a little experiment here myself. Oh, there's the signal generator. Okay, so right in here, when you look around the 460 mark, you see what might be a response curve. That's what it looks like. That whole, this whole curve here looks like a response curve. What I was noticing was that there's a lot of action up here, but not much down here. I was just tuning around to see whether that was always the case, but no, it isn't. It isn't. Okay, back to 800. Back to 800. Bit of a quiet spot near 800. Ooh, right in there. We'll call that quiet. Now I'm going to tune the signal generator to 800. I don't think you can see the frequency counter, no, but you'll just have to trust me. So we're heading for 800. And a weak signal, let's put a little more juice in it. Lots of juice in it now. Here we go. 650. Is it on the screen yet? No, it won't be on the screen until we get right close. Because we're not really, well, keep going, don't talk. 700. Oh, what was that? Let me go back a bit. I don't hear anything coming out of the speaker. That's 705. 705. What? Well, that sounds like double 460. The double 460. Okay, let's just keep going. I'm not sure what that was. Okay, we're at 725. 750. We should be coming up pretty soon. Oh, there's a little something there. 760. Here it comes. Look at that thing. Okay, I'm going to turn it down a bit because it's just a little bit of a killer there. Here it comes. You can see sidebands on the signal that's coming. That's because it's modulated. If I kill the modulation, the sidebands disappear. Put it back up. The sidebands look like two peaks because I'm modulating it with a sine wave. Just a little high on the modulation there. There we go. Coming down, down in frequency. Up in frequency, sorry. 780, 790, 800. There's 800. Well, we're nowhere near. I certainly have this tuned to 800 here. Okay, so we're going to force the signal that's coming from the signal generator onto the 460 by tuning it. I lost track of which one it was. Which one is it? That one there. It's that one. Okay, we're tuning it the wrong way, other way. Let me just see if I can't make this look a little less sensitive there. That's a little better. Whoa. All that stuff. Okay, so I'm still kind of pounding my SDR with a ridiculously strong signal here. I'm going to knock it back on the signal generator. Now we'll tune it in. I never heard it. How come I never heard it? How come I didn't hear that? It's a very low signal I'm sending over. Did I lose the signal? Okay, I'm going to put it back up. Maybe I lost track of the real signal. That's a thing of beauty there. Let's see if I can just shrink it some more. Not really. Let's see about AGC. I don't have much luck with controlling the AGC on the SDR I'm using. It doesn't seem to respond, so I don't really know how it's doing it. I'm sure it's doing something. So what do we got now? So we got the radio receiving 800. The radio's tuned right on, so the conversion is coming right at 460. I'm pretty sure the IF is tuned to 460. It's all making sense. Except what's the dial say? What does the dial say? Ooh, did you fall over just now? Hope not. 780. 780. So either the local oscillator is not where it needs to be, or the dial pointer is incorrect. One of those two things is happening here. The local oscillator trimmer could be used to correct that. Why don't we do that? So what I want to do now, I want to tune the radio so it's right on 800. And now I want to adjust the local oscillator. Use a bigger screwdriver here for precision. Can't get it much more precise than that. Sounds like it's not quite right. The curve is not quite right. Screwdriver's not having any effect. Bang on. Reads 800. I'm feeding it with 800. The local oscillator must be 460 away, or this wouldn't happen. And I'm pretty sure the IF is tuned properly to 460. We're going to prove that probably tomorrow. And we'll do a sweep alignment on this radio. And we'll find out some more stuff about it. Okay, now having done that, since you're trying to make the local oscillator and the frequency it's converting things to line up with the front end tuning on the radio, line it up. Don't have it out of alignment. And if I did align the radio properly, I've now moved the local oscillator trimmer. I got to move the antenna trimmer. Can we see this effect? Good question. I don't know. Somehow I don't think so. I'm really trying. Let's cut back the signal here. How come the waterfall got wide? I'm not monitoring the AVC voltage on this radio, but what could have just happened is the AVC has relaxed. Where'd the signal go? The signal completely disappeared. And it looks like it's a little off to the side. What happened to our nice signal? It just turned into a... losing track of things. So I think the wide thing we're seeing is a noise signal. Yeah, because I went to 800 without looking for noise first. Okay, let me move the signal generator right off. Okay, so the signal generator is, can't even see it on there because it's so low. There it is. It's way off. It's way off on the left. So I've tuned the radio right onto some noise spot. This is not good. Let's find a nice quiet spot here, if there is such a thing. A little bit of stuttering there. Yeah, I stuttered when I was a kid. Oh, son of a gun. So no, noises everywhere. It's getting pretty quiet up here. What happened there? What have I done? I've tuned this radio right down. It's below 600 now. Right down to the very bottom. Okay, find a real quiet spot. You know, if you're doing an alignment with a voltmeter, the voltmeter is responding to all these signals, and you can't tell necessarily what's going on. Can we call that a quiet area? Let's call that a quiet area. Turn the radio up. Pretty quiet. So I will turn the signal generator now to match that. Where are we tuned to? We're tuned to about 56. 56. Okay. 560, what I really should say. 560, right around here. What happened to it? What's wrong? Oh, I'm at 660, that's what's wrong. 560, here we come. Oh, turn down, turn down, turn down, turn way down. Okay, this would be like a weak signal, I think. I can see it quite clearly now. Turn down even lower. Make sure that's it. Yep, you can still see it. I'm making it go back and forth. Okay, a quick review. SDR's looking at 460. The red line's on 460. Right? I have the radio volume very low. I've got it up high now. Modulation is... cannot hear any modulation, but you can see the carrier. That's pretty interesting. Frequency is 540. The dial says 570. The dial says 570. The signal generator says 540. What happens at 570? This is 570. And nothing happening. I moved the local oscillator previously. Could the radio just... You gotta imagine that at the band ends, things get a little difficult to keep everything nice and linear. And I think the evidence of that, when you look at the dial, so the dial is not linear. One of the last stages in solving radio problems for the radio engineer is to contrive the dial to match the behavior of the radio, because they just couldn't get it any better. So down here, 5 kilohertz is this big, and up here 5 kilohertz is this big. So there's a crunching going on. There's non-linearities in this thing. Could it be that far out? Okay, double checking where the signal is. Yeah. So the radio's tuned right on. Okay, I'm going to use the local oscillator to force it back. This is far more revealing than just doing this with a meter, Helpful? I'm not sure about that. So now what I want to do is I want to match the dial setting, which I'm going to look at very carefully. 560. We can call that 560. I'm going to put this on my signal generator to 560, which is what we should be hearing. Disappears right off. 560. Okay, we're on 560. I'm going to get a little more oomph here. You can see it for sure. Now I'm going to move it to where it should be. And with the extra oomph, I'm sure we'll hear it. So I've opened this capacitor all the way. All the way it can go. There's no more in it. Huh. The screwdriver had a small effect there. So we're picking up 560 at 560. 560. So if we go up to 1,000,000, no, I don't want to do 1,000,000. Do 900. Okay. I'll tune the signal generator to 900. Here we come. That's 900. Did anything show up? Oh, look, it's way off. It's way off. Okay, a little more juice. There it is there. Okay, so if I tune this to where it really wants to go, okay, so you hear the tone. Now you know enough to look for an interfering signal, and sure enough, there's one right here. This guy right here. And that's what we're hearing. So I have the radio set to 900, but the signal generator is running at 940. Signal generator is higher than the dial reading. Let's go up to right to the other high end here and do this. I'll set it on 1500. Okay, that's 1500. Right there. Now we'll go up, go down to 1500. Signal strength would have changed when I changed bands here. Even when I go a distance with frequency, the output of this signal generator changes a bit. That's 1500. Anybody see it anywhere? Is it showing up? Now what we're looking for is the converted version of the 1500 in the IFs. Go higher. Oh, if this doesn't show, then something terrible has happened here. Oh my gosh. Almost 17. Interesting that I don't hear the modulation. And if it's insufficient signal coming out of the IF string into the detector, and it's insufficient to get over the diode, so to speak. If that even makes sense. If I give it a little more juice, there it is. But here, the carrier's present. But I don't hear any modulation at all. Nothing. Just like yesterday, there's just piles of, I should be making notes, there's like 1,000 things to look into here. So if we do set this to 1500, 1700, it's way, way, way off. Way, way, way off. If you don't believe me, there's 16 right there. Oh my gosh, this is really opening my eyes to. So typically when you're doing alignments, you're doing them at 1 or 2 frequencies, just fixed frequencies. You set the radio, you do the thing, and you go, hey, there you go. And what you're doing is you're making it work at that location. But as soon as you tune away, sad things will happen. Okay, let's see if we can adjust the. So set this to 1500. Just disappeared. Wow, that's a long ways away. 1500. I'll jack up the power so we can find it. No, not coming through at all. Probably closing this capacitor is going to bring it in because I can't open it anymore. Anybody see a signal? Did I just hear a radio station? No. screwdriver fell out of the slot there. Okay. Holy smoly. Okay. I'm going to cut down the signal generator. In fact, I'm going to throw it off frequency. Throw it off frequency. I'm going to turn it. Was that just a whopper noise signal in there? Yeah. Okay, so that's a bit of a problem. So 15 is not a good place to do this. I gotta stick with it. So I think the... Okay, turn this guy back. 15. Here it comes. That's terrible. Of course, you know what's happening now, right? Because there's a noise signal there, and I'm bringing in another signal. The difference between them, which is the audio, which produces the audio, as I move the local oscillator, that distance is changing, and so the pitch is changing. Okay, we're right on 1500. Looks like we're buried in the noise signal there. Okay, wait a minute now. 1500. I thought this was way off. Oh, you know what's way off? Me, I'm way off. What was this other thing? 17 came through. What has happened? Okay, something. I changed the setting of the local oscillator. That's what happened. I'm just forgetting what I'm doing. Okay, 15 is right there. It's just right on this noise signal. So now we've got the radio working properly at 15, but it won't be working at the other end. As in, it's way off. You know what? It's coffee time. I got so much stuff now in my head. Wow. This is really has highlighted some stuff. It's highlighted the fact that I need to drink more coffee for sure. Yeah. Break time. Wow. Okay, just gulped coffee and came right back in here because this is pretty interesting. I'm finding this quite an eye opener. What to do next? I've turned the radio off for now. I'm finished for today. What we've discovered here is you can't align this radio on the dial. That's what it looks like at this point. Maybe there's some more that could be done. I don't think so, offhand. So that raises a question. Is this how these radios came out of the factory? They all came out like this? Fat chance. Fat chance on that. So something has happened in here to cause this. I did not really look at the local oscillator frequency. Well, let me put it this way. I guess the problem has to lie in the linearity or the matching or the alignment of the local oscillator against the dial as you move up and down it. So the local oscillator is supposed to go from here to here, but instead it's going from here to here. Something like that. Or the opposite, from here to here. Across the dial. There is a way to accommodate this problem, and it's by bending plates. Oh, I had a terrible experience bending plates on the last radio I did. Ooh, I really mucked it up. This guy's off. Let's just look and see. Are there any plates bent on here? I'm looking at the... not really. Not to any great degree. These outside plates can be bent away I reduce the capacitance of the capacitor and change its linearity or non-linearity or whatever you want to call it. This plate looks like it's out a little bit. That could be because it was done in the factory, or it could be, who knows how that happened. The plates are split. They have splits along them. So when you bend the plate, you don't bend the whole plate. You can bend sections. You can bend one section out and the other section in. And this would really change the tracking. Maybe that's the right word. The tracking of the local oscillator. That's probably where the solution lies for this. I've really not tried doing this kind of thing, this plate bending thing. Literally because I didn't know what I would be doing. How would you know? Well, it strikes me now that you could see this. In fact, maybe with some luck, you might have a radio that's good on both ends and out in the middle. And by bending those plates just right, you can affect the middle and leave the ends okay. This has to be the secret. Now, how this was ever done, I guess you could come across the band and stop, every 40 kilohertz or 50 kilohertz, and get your signal generator set and get this set. Remember, back in the day, people didn't have digital frequency. They didn't have any way to really know for sure what frequency their signal generators were running at. You'd either have to be recalibrating them with some calibration standard regularly, or who knows how it could be done back then. They'd only be the very best labs. No repair shop on the planet would have the equipment to do this kind of thing for these kinds of radios. There could be some techniques that guys knew for accommodating this problem, if you could even recognize it. So tomorrow what I'm going to do is I'm going to just continue on. I'm going to move even further down the radio. We'll look at the output of the second IF transformer. Should be the same, only better, sharper, cleaner. And then after that we can move even further, I guess. Maybe not. Maybe you can't go any further with this kind of testing, because the next thing is the detector. And yes, there's RF all over the detector, but then there's the rectified RF, and the RF component is being suppressed by capacitors strongly, so it may not be too much to see on an SDR. That's exactly why we should look. Okay, so tomorrow I'm going to move the capacitor to, well, this is a bit of a problem. You see, right now I'm on the plate of the RF tube, and it's a relatively low impedance circuit, quite low impedance circuit. So I can't muck it up too much by doing this. But on the other side of the second IF transformer, that's a higher impedance area. The next lower impedance area is right in the detector circuit and the detector diode. That's where I think we got to go next. And what are we seeing there? Well, actually, we are seeing the output of the second IF. Okay, I can work this out tomorrow a little better. Ultimately, in the end, I'm going to align this radio using a sweep generator, and having got in my head all these things I've seen about it. Good. That's good. That was interesting, and I'll be able to reproduce, do these tests again on other radios. The next radio I'm going to bring in here is a Hallicrafters radio I worked on about maybe 8 months ago, and I had to stop because I had to move on to some other projects. But I can bring that radio back in here, we can finish it off. I can use my insights from doing this kind of thing to try to get wind of what was up with that radio. Something weird was going on with that one too, and maybe using this technique would allow me to see what's going on with it. So that's what's coming down the road. I'll bet you I'll be on this radio for a couple more days. And don't forget now, the whole thing about this radio is not the radio. It's this guy. It's this sailing the high seas. Look at that. That's what's really cool about this radio. Maybe, yeah, maybe that goes together. You put the cheapest radio you can in the fanciest cabinet. Sounds like a sales approach. Okay, thanks a lot for watching, and see you on the next video.